probably be referred to throughout the presentation because he's also very familiar with the machines. Thanks for coming. For those who are coming virtually, we appreciate your attention as well. And we are going to record this and have it for viewing later. So excellent. Come on in. Welcome. Make sure the door stays open in case other folks come. And, welcome you guys here. We have masks if you want one. They are actually voluntary at this point. So it's just a very exciting to get to use Flex as a kind of like a megaphone, for that lack of a better word, of announcing to our faculty and our staff and our students that the CRC Makerspace is finally open for business. And so what I like to do is, the list is very long to kind of formally thank a long list of people who've been instrumental in helping us get it going, but it starts at the top. Los Rios has supported Makerspace development at all 4 of the major campuses. Luckily enough, here at CRC, had a lot of folks making sure that the money gets down and developed into this. And I've been lucky enough to be here from the beginning. Lane Hurtado is another one who's helped been here from the beginning. And so step one was where to have a makerspace, right? So there was a lot of thought about, if you're here virtually, where we are, we're actually in room T117, kind of near the old technology area. This would actually be the AutoCAD, architectural design technology computer lab. When they moved that program over into the Wind Center, this room was used by a number of other programs, and we were able to get it as the selected spot on campus. I think it was very valuable real estate to just get a room this size. So once that was developed, began the process of laying it out and added a room kind of locked in by itself, so that kind of contained some of the more dusty wood-like projects, and so that was part of the original design. I think what I like to do is just kind of first offer anybody who's here in person, if you guys have questions, I'd be happy to give you the opportunity to, instead of waiting for 45 minutes to ask a question, if you guys might have questions about our CRC Makerspace, how about an opportunity to ask questions before we get going. And actually, Eddie, how about in the Zoom land, if people want to put some chat, if you can watch for that, we'd be happy to kind of interact with folks who are here. Folks in Zoom are welcome to interrupt. I can't see you very well.
Hello, Ryan and Eddie. I have a question.
Oh, we have
shout it out. I was curious how we're going to handle access to the makerspace for students. Are we going to have set hours where it'll be open for them, or does it have to be kind of by appointment? They come with the class with the professor or something like that.
That's a great question. And so the question was about open access to students and staff and faculty. So right now we were able to work with our colleagues at Sac City. They allowed us to kind of utilize a lot of they have written a lot of maker curriculum, which means it's actually coursework for credit. So we picked 2 of theirs that really best fit just to get the ball rolling here. So we do actually have 2 classes this semester. One of them is first 8 weeks. It's called Maker 140, MAKR, and the modern making is the actual designator. It's I think it's variable. I think it could be up to, I think it's 2 units. It meets Wednesday night and Friday. And then in the second 8 weeks, there's a 1-unit class that's all lab, and it also meets Wednesday nights and Fridays. That's called Maker 151. There's open seats available still if you have interest yourself or want to spread the word to your students. But if you're just curious, which a lot of what we're able to do, actually Eddie Maximo, who's helping today, is we're looking to have the Makerspace open Tuesday, Wednesday, and Thursday, 8 a.m. to 1 p.m. It's the initial open door. And Eddie's working on the protocols for tracking students using probably student ID or employee badge and tracking who's been trained in what equipment, because what we can't do is let people just come in and start pushing buttons. We're going to have like little orientations and individual trainings for the various equipment that I'm about to show you. And so, whether it's Eddie or one of our student helpers who can, when you walk in and check in, in fact, Eddie, if you want to see, this is actually the front door to the maker. We have a check-in station where you'll be able to check in, and on the screen it will show whoever's monitoring the room. Oh, look at me. I see that you've been trained in the water jet and the laser. So if that's what you want to do, then go ahead. And if you say, oh, well, today I want to learn about the 3D printers, then maybe we'll have an online video or something that will kind of orient you and kind of work into that. So I hope that's actually the best answer I have right now for that. We actually are just now, the way I think it in my head is, I'm so glad the new normal will include the Makerspace, because we want to encourage people who feel safe to come in. We'll have masks for folks who want to, but this is really a brand new attempt for us. We're going to continue to develop how many hours we can stay open. Each of the campuses has their own individual funding mechanisms to keep the doors open and the lights on and staff.
We have dedicated staff for it.
Oh, so right now, Eddie is the dedicated staff. He's the lab tech. With those come limited hours. It's not a full position. Hours, and I think 9 of them are dedicated to the weekly. It's a lot of hours. It's actually 3 hours. So the classes, the formal coursework is 6 to 9 Wednesday and like 8 to 2 Friday. It's pretty heavy duty. But if you're working with some of the software and you're doing some of the actual design work, we can let you do that from home. Files. So part of this room, most of the things in this room require a file, some kind of computer file that then gets put into the equipment. An example of that is I wanted to learn software. I'm very proud and skilled tradesperson with woodworking, but I don't know the language of computers. Some of Eddie's helped my skill development. And an example is I play the card game cribbage, and you can go online and buy a cribbage file for like $5. I spent like 12 hours putting one together, chunking it together with the software, because I wanted to learn how to make the software do what I want. So we will have some options for if you just want to build, like we have a friend who just wants to build a guitar. He's already purchased the file. He just wants to come in and load the file and do it on our CNC. So he doesn't have any interest in learning the software. He just wants to make this stuff. So Eddie and I are going to work with individuals to kind of meet either demand. I'm going to kind of try to encourage folks to learn how to use the software, but there's also options to just buy someone who's already made the file, and now that's how they make it. Hopefully we didn't kind of diverged off of the hours. The truth is, we've recently developed the hours that we just said, with the Tuesday, Wednesday, and Thursday mornings, really from 8 to 1.
There is a question in chat. Is there any charges for the sewing machines? Is there a limit on the amount of time for the lab course? Is there a minimum amount of hours for the lab course?
Yes. So the actual coursework that's for credit, the Maker 141 class is, I think it's actually 18 hours of lecture and 54 hours of lab. It's kind of, it's been scheduled out on Wednesday nights and Fridays. And the difference between the first 8 weeks, which is 2 units, and the second 8 week, Maker 151, is that Maker 151 is only lab. So, and if that will work out, it's the pilot program, right? We're doing what we can and what we got, and this was the way to get, the lights on, and now that we've got Eddie to help with some ongoing hours. So yes, there are hours for the lab. And then the question was about usage of the equipment and I interpreted the question as consumables. Is there a cost for consumables? And the answer right now is in the class, if you're actually enrolled in the classes, I'm going to go ahead and say no reasonable amount of material used will be charged to the students. If you want to build a solid gold chess table, you're gonna have to bring in your own gold. We have, if we have some material, you want to, gentleman who wants to build a guitar, he's gonna buy the material because it's a personal thing. But for you to experiment, learn, here's a perfect example. Right, we were asked by our automotive program to build a differential wrench, something that they can take apart differentials in the car. Yeah, they gave us a hand-drawn picture. We drew it up in the software, and we found miscellaneous chunks of scrap metal that we could cut it out. We didn't charge it, but we have that wood, we have plywood, we have cloth, we have foam, we have a lot of stuff that we have pre-purchased with the intent to help students. We knew if students were going to drop $50 to come in and experiment, we wouldn't get students. So we have some foresight of spending money that we had, particularly during the quarantine, to stockpile basic materials so that students can come in and learn. So, but you know, if someone comes in and starts making speaker boxes and wants to use up all our plywood, the answer is use our stuff to help make your prototypes. But if you're going to start a small business in making car speaker boxes, plywood and use our machines. So hope that helps. Thank you guys for your patience while we were taking questions. I kind of knew that it was going to be. Hi, come on in. Hey, what's happening? Appreciate you coming. We just haven't really started our tour yet. A lot of people have asked about access for the faculty, staff, and students. It's coursework available this semester, and then we're going to try to have open door policies Tuesday, Wednesday, and Thursday from 8 to 1. People, students, anybody who's got a Los Rios ID number is welcome to come in. We're not really prepared to have people from the general public come in quite yet because that's a whole insurance thing that we haven't figured out. So why don't we do this? That was, I appreciate the starting questions. We're willing to take more as we go. What I was going to do is introduce you guys to the capabilities that we have. So, I can do one time through just to kind of show you what's here. And I think time will permit for us to kind of, we got stuff lined up so you can see how the machines actually work. And so with that being said, you guys go ready for it? Yeah. All right, so it's pretty common for makerspaces to have 3D printing capabilities. So what we got, this was kind of designed to be our 3D printing area. We have access to some smaller machines that aren't set up. These are called stereolithic printers. They actually
Photolithic.
Huh?
Photolithic.
Photolithic. These guys actually can print. There's a laser beam projected into a pool of resin on the bottom that solidifies the resin, and then it lifts up. It's actually pulling the shape up out of a pool of resin because it cures the resin and then lifts it. So we've done a couple of things. We needed to do some dust collectors, and so we got to printed our own reducers here. Eddie's done a number of really cool things. I think we've had our, I think the architecture students were printing things here late in the spring. This one cracks me up. Eddie scanned my head with his phone and printed a bobblehead. Can you just show over there? That's a lot of other little trinkets and things that have been printed. So I know that different programs have different interests and all that. Expecting the engineering students to be using the 3D printing. I've seen online a lot of people printing cool little caricatures and things like that. So we also are looking at developing other kinds of technologies and buying other machines that do different kinds of 3D printing to kind of grow this area. We also happen to have epoxy resins for doing epoxy projects, like various size river tables, cooling boards, things like that. Kind of take a look this way. I'm going to open the door. I don't know if we all want to try to go in, but you can definitely stick your head in. Yeah, this was designed to be able, this big center bar comes out so that you can wheel plywood in and stock this machine with plywood. You can program it from the computer outside, get it running, close the doors, and it's actually, you can still hear each other talking out here. As long as it's
Nice.
It's got a great vacuum machine that actually holds the material down, so you're not programming to go around your own screws that are holding the material down. And there's lots of our architecture students competed in a design build competition where they designed a structure they could sleep in, but then they had to take it apart and pack it into a camper. So I can't remember exactly what the name that's called. That's the competition. They came in, Eddie helped them do their designs in the software, and then got them cut out. And we heard from our architecture faculty that they won 2 awards this year after having not won for a while. So pretty impressive. Huh?
It was at Cal
Yeah,
Poly.
every year it's at Cal Poly, and there's both 2-year and 4-year schools competing at that, I think. So it was good. So another example of this is the machine that you can buy the electric guitar profile and carve your body and your guitar out. I'm actually excited as a construction teacher. We do work with our local affiliate of Habitat for Humanity. We build to help them. This machine, we have software that can do cabinets. So we can actually help look at Habitat's designs for their cabinets. And we can teach our students how to kind of do it in the software. And then we can cut a couple of them. And they only build, I think, 6 to 10 houses a year. But I mean, that means we can teach our students how to maybe give them an idea of the traditional way of cabinet making in our shop. That's unrelated to here, but then also teach the advanced manufacturing. So there's lots of opportunities, and that's just my own little small vision. But there's lots of other people who have visions of how to do it. I think it's pretty cool if you come in, and we also have wood turning. So you can come in and make bowls and pens and things. We've got a pretty nice little area. We've got a little table saw for ripping small material and drill presses. So this is just kind of our woodworking room. We've got really nice equipment, sanders. You guys know what a domino joiner is? Festool domino joiner, planers, sanders, nail guns, and just about anything you kind of want to build. And luckily, Eddie, who knows, if need be, we could even borrow equipment from other facilities like the construction program. If somebody had something that was too big to do in here, we'd try to allow them to come out and work in the shop, the big shop out. Out and around. This was always designed, this was kind of designed to be our original laser printing and laser cutting station. So we've got 2 pieces of equipment over here that can run lasers. We actually have a 3rd one across the hall that I'm looking forward to showing you. We have 2 because they're pretty common and pretty popular. So we're hoping to be able to do 2. One of them is a little bit nicer than the other. Actually, this one has both fiber optic and CO2 type technology. So the other one is, I call the other one the Ford pickup, and this one like the Maserati. One's kind of daily driver, and one's kind of the fancy one. We also have this awesome machine right here, which is CNC mill. While it's not got a humongous capacity, it works just like the big one. So you can carve quite a bit of things in here. We don't, well, we have aluminum, we've got copper, we've got steel, we've got quite a few. I don't know if you can see these buildings down here. We actually purchased some for big. I'm actually going to make. I'm going to make a trip. That's very simple, but it's very geometric, very easy kind of entry level software stuff for me. Can I show it?
Yep.
And he's gonna make fancy golf cart. Print it on the 3D printing machines first, and then you can show your golf cart. You know, with the right stick, you know, this could be your printer. So this is 3D printed, and then that exact same file that Eddie created can be loaded into this machine and can actually mill it out of a solid piece of metal of his choice. I wish I was a good golfer and knew what putters are made out of, but I can. Little Google search probably. So, and then we also have, this was designed to be kind of an electronic station. So we've got soldering, circuit board, just kind of different electronics. We're also going to look at including kind of developing some AI, artificial facial recognition, different kinds of things here. You know, these drawers are just full of those kind of things you need for electronics. And he's playing with a small drone that was given to us. This area was going to be a textile area for sewing and other kinds of things. And we were blessed enough to get another room across the hall. So I'm excited to show you that one. But that's why we actually had the two drop downs. So we knew we were going to have an electronic station. We thought there would be a textile station. You can see we even knew it was going to have to be on wheels so that you could reel the plywood in to keep the open path here. Layout, I thought we did a pretty good job. A lot of smart people thought about how to lay this place out to make it as functional as you can. Because it's actually pretty noisy, I thought I would take a minute and introduce you to this machine right here. Because this one, you can actually see it's actually got a pretty big footprint in the building. This is a water jet for cutting. Actually, it can cut stone. It can cut through 3/4 inch thick steel. It's what we cut the wrench on. In fact, I think it's just so dang impressive. You know, we actually had it doing our first cut. It didn't cut all the way through the first time. It cut through the circles the first time, but not the long ones. I realized it was going too fast. So we had to we're still learning the tool path functions. And then, you know, by slowing it down, it actually cut through this much thicker on the first pass. So it's really how, you know, just we're still going through the learning process as well. These are examples of things of what I think is impressive is the same machine that can cut through 1/2 inch steel. It can also cut precise. It could cut as precisely as it can, and also cut very intricate little things through thin material too. And so it's kind of loud. It's pretty impressive. I thought if we fired this guy up, we wouldn't be able to talk to him. So I thought, why don't we show you this one, and then we'll walk across to the room across the hall, and I'll kind of do an orientation over there. So if you want to take a look, what we've got it set up for is it's just the same file. It's just this wrench because we're trying to get it just right. I think we got it, but it's an easy one to show. So the way this guy runs is this machine runs on 60,000 PSI of water running through a very small orifice, which right now, if you want to look in, you can see. So we have it. It's also supposed to cut, you know, about a 1/16 of an inch off the top of the material. Pass that around. It's shooting. So when you hear the machine kick on, you'll know why it's doing. It's creating 60,000 PSI of water pressure. And then that you can actually see it when it runs. You want to put this guy down. It's like a toilet plunger. There we go. I want to touch them, but I don't want it. That kind of keeps the overspray down. Make sure it's matched. Basically, what we're doing, let the machine get kind of fired up. Got visual lights, so you know, in addition to the water pressure, it uses a cutting medium, like sand, a very fine sand that acts as an abrasive in the cutting process. Pot is actually stored. There's a little glass jar, looks like a purple sand. That's the abrasive going down into the helping make the cut.
Hold on. Can you? I'm going to turn on the compressor. Okay.
Well, pick up where it left off and some stuff in the middle.
So, no, we got the wrench or the pump.
Or either one. Did it actually start cutting even though you didn't have the compressor on you?
Yeah, so it didn't start cutting because I did. So what we do is we turn the pump on. And then stop this kind of. This stuff that tells the machine to go, that kind of runs the gantry. It has like a system of ways it tells you, okay, pump's on, ready to go. It knew that we forgot to turn the air pressure on. It's pneumatically, it's air pressure that pushes the cutting medium. We pushed into the water pumps pumping water, but the air pressure is pushing the same. She knew, got distracted, forgot to turn the air pressure back on. So let it get going and it would, so we kind of slow it back down. The only thing that was really going was that. So, green light says go. Now I can tell the gantry to start running. Interestingly enough, if you look, you see how it sits in a grid? Look down here, it's actually telling me where it's set the metal in there based on the grid that it sits on. This grid is actually the metal grid. So we counted 3 squares over. 1, 2, 3. 2.5 squares up. Place this and cut it over. We're not going to run into our own place. That was kind of anticlimactic. Huh? Huh? So?
Yeah, it's just.
Not said exactly right. It doesn't even blow up all that. This is P116, right across the hall from kind of the original P117. We don't really think of them as, call them, but usually I refer to this as a textile. Essentially, this room has a kind of a customized and like computer controlled custom embroidery machine. So Hurtado, who's kind of the one running this one, like printed this. You know, I have a picture of my new fishing boat. I want to make a little custom hat with my own boat on the front. In fact, she made our shirts, the Makerspace.
Nice. I was wondering where you got that.
Yeah. So I mean, this machine can be programmed. You import. Again, you make a file, whether you buy one for something or you sit down and use some software program like Illustrator or Fusion, and you create something, and then you can upload that file into these machines. And it's a little bit tricky because each machine has its own kind of proprietary software that makes the motion, the path, the computer says in motion of the machine. So there's Eddie, fortunately, is pretty good with everything over there, and Lynn is pretty good with everything over here. So she's got this kind of stuff going. It also we have regular sewing machines. This machine, actually, we bought it because it has the strength to do leather. So, it's a machine that we've also got a couple of standard regular sewing machines. But I like this one because I want to make a wallet. That'd be cool. I don't know if it's quite strong enough to make like full construction leather bags. I'm not too sure about that. That's kind of my jam. If you come around here, I'll grab this. I want you guys to be able to see this end of the table. This station has leather on one side, so you've got lots of small little leather pieces of things that you could use. You can bring in your own leather. We've got larger sheets of it, and then it's got like all these cool stamps that you can kind of smash in and carve in. As a matter of fact, this reminds my dad had something like this when I was a kid. It's just a cool little leather flap on his keychain. I don't know if you've ever seen one. I just thought it was cool, so I made one. Anyway, and then the last thing I've got over here is this is a stained glass station. If you take a look over here, it's got we've invested in lots and lots of different kinds of shades of glass that are all kind of pre-cut to small billets, whatever you want. And then we've got the tools to etch, cut, solder, and shape and make small stained glass stuff over here. And we ended up with one additional laser. And so this machine is great. It's still cut up in a pretty big bed. Also has its own purifier, but we have one additional laser over here. We do anticipate the lasers and the 3D printers being kind of heavily utilized or played with. So, and then this cool, not only is it a cool cabinet, this actually has 5 or 6 laptops in it that can run a Cricut. Does anybody know what a Cricut machine is, or how would you describe what they do there? They're kind of like small printers and cutters that you can program. I've got friends who custom made like their own wedding invitations, and they're very professional. They're pretty nice things, and so I can't help but show off this cool cabinet. It's like the coolest cabinet I've ever seen in the world. This has multiple Cricuts, lots of material that you can feed in and cut with and fabricate with for various things. So when we were asked very early on, like, do you have to like get your own thread? And the answer right now is no, we got thread. We got to buy our own paper for the Cricut. No, we got paper. We've got leather, we've got glass, we've got wood, we've got steel. So we've got tons of resin for the 3D printers. And at some point, we're going to have to come up with a sustainable way of saying, okay, you printed your first one, something was wrong. Printed your second one, oh, it's almost there. You printed your third one, bam, now you got your file, right? But if you want to print 30 of them and sell them, then you buy the rest. There'll be some kind of way. We can't just give away the stuff, but we want to encourage students and don't want to discourage them because of the cost of learning how to utilize the equipment. So that's really the Makerspace facility. We are going to try to have open access. We also want to encourage, we have some interest with other faculty members already where they're going to incorporate lab work, like in engineering specifically, where they'll have projects that they will come over here to print or cut, or then I mentioned architecture also, where they can actually come print small. We got a 3D printer that can print pretty big. I'm going to bring my construction students over to do the cabinetry and the woodworking. I'm going to encourage them to consider taking the software class to help kind of learn how to create stuff with software. And the two that I'm most familiar with are Adobe Illustrator and Fusion 360, which is what, luckily enough, Eddie was helpful in translating. Those two softwares can be pretty much uploaded into any one of these machines. And each one of them has their own proprietary stuff we provide. And with the CAM software, the stuff that moves the machine, you got to use theirs, but what you can upload it to. We have kind of like a few universal software that we have in there. All the computers in there have them. And so people who, like myself, who have very little formal knowledge of how to do this kind of stuff, can come in, learn, utilize our software, our supplies, and our facility to come and learn.
So your initial maker class will be teaching the software?
Our initial making class is set up kind of like a work experience class, meaning students can come in and kind of pick their own learning objectives. And I will sit with them and say, because there's not enough time to go become good at everything. And we're going to encourage students to learn the software. I'm also expecting some students who are already really good at software. That's why they're coming to class, to make all the cool stuff. So we're trying to make it very fluid and kind of cater to what students really want. We're going to approach the lab, the open lab, the same way. If you want to learn some software, we'll try to teach it. If you already know the software, we'll teach you how to use the equipment. Safety is a big issue, a really, really big issue. So that's why we can't just say, hey, we're glad you came, go ahead and start playing with some stuff, because safety, student and faculty and staff safety is paramount. But the machines are expensive and they can get banged up real quick, real easy. So we just need to make sure that we're training everyone on what the tool needs, how to use it safely, encouraging them to be creative, try new things. So the answer is, we're hopeful that people want to do the software, but we're going to try to stay as fluid as we can and say, if you know, we have a pretty good idea of how long it's going to take to kind of learn each machine. So we're going to kind of let people who might want to do stained glass, do stained glass. People who want to do laser, do laser. We're going to try to make it fluid like that. That might be kind of utopia, but that's what we're hoping for.
That's great.
So.
There was a question earlier on how to make an appointment to bring like a class to check it out.
Oh, I would say you can email me. I can put my email in the chat, and I can put you in touch. We can sit down and figure it out. That's, if you want to bring. I encourage, actually, I really encourage other faculty and staff to bring their, folks from their department and just come see this place. And as we've been developing it over the years, people stick their head in, everybody from the president to the janitor. Everybody's really, really impressed with it, right? So we want people to come. It's just a place where I'm excited. We don't have another place like this on campus. We have cool places, but not one like this. And so to make an appointment, I would anticipate. I can type my text in the chat real quick, or can you type it in for me? So my email is CONNALR@CRC, the rest, losrios.edu. And I would be more than happy to set up the time where I want to make sure we do that. I want you to bring your students. And yeah, just so you guys know, there was very little like advertising done. That it's because the designator for the classes are unique to this campus. We had really low enrollment. Actually, there's 6, and there are 6 open seats still available. We'll say that in the Maker 140 class that starts next Wednesday. So if anybody's interested or knows somebody who might be, please tell your students. I don't know.
That's just for the whole thing altogether, or just for one particular element of it?
So I think what's going to happen, if we're open 3 days a week, people are going to come when they can. I'm hopeful that we'll get students from. The reason we wrote the curriculum that we did was because our hope was that architecture would actually substitute the 3 units of Maker in for something that's part of their transfer program, or that the engineering could take out some kind, literally substitute Maker coursework in. We're also thinking though that it's probably the long-term usage is going to be where those other programs, theater arts is another one where making costumes and the stage, the sets, maybe it is just theater art classes. They've got a great shop, but maybe they might come over and make something specific here so that they're using this as part of their lab in their own designations. We don't really, we're excited to try it both. At other campuses, there are entire certificates in multiple classes, all relative to advanced manufacturing. I don't know, for us in the funding streams that are available, even though we had really good equipment and supply money, we didn't have a lot of people. So for us, does that make sense? Getting faculty to just have a class and get an FTE to get it going was one option that we chose. And then now that we've got some option for some like 3 days a week to be open, we'll see how that goes and get some sustainable model for that. So what do you think we can go? You want to try go back over there? I'm not confident that thing cut over.
It's 50-50.
When I saw all that overspray came back, I had a feeling that we ran into the same problem. And it didn't cut through all the way the first time. We'll see. That's definitely user error, not machine error. All right.
Go to the laser.
Order screen, you can see. With the software, you can tell it what you want, you can give it the dimensions. As long as you be able to see that. But we're going to cut another one of these. I believe Eric Anderson did the design for the engineering box. Absolutely. I'm not sure if you saw the software side. But the machine can be both cut and burn. So you can burn pictures. No, this one can work on, this one can etch with the metal. We can go on the white flag and add a piece of steel. Thanks for all your support. So I don't believe it can cut through even thin metal, but it can etch into like solid metal. And then you can burn or cut through. That's it. So this is just an example. Watch what it's doing. It's basically just a fancy printer instead of spitting ink, it's shooting lasers. Watch it. Start to smell the wood. Oh, you gotta get a dust extractor? Yeah. And then
And then the pump on the left.
up on the left. Starting to suck out the fumes. So that's both of these machines have their own fume extractor. Right? It does. This the screen actually is enough to, you know, you can burn your eyes looking at a road. This screen is supposed to be enough of a shield, like 10 you look at it left or just go through and cut. This is one that I can do. Does this one say how long it's going to take?
No, this.
How long you should expect. It's not noisy. But it's what it does. First thing I did on it, I made a picture frame for my sister. That's what we're making right now. Actually, that's how it's like. Yeah. So, you know, Katie's got other cool little keychains and things that have our hot logo on it, a lot of school logo and school branding. Right now, it looks like what it's doing is just burning. It cuts it a little bit more intense and full, and it's going all the way through. With the box ahead, you see it's pretty active. With the saw, when you're cutting, you know, part of the wood disappears in the sawdust. So this tool and that tool, part of their accuracy comes from is how focused on a straight line. You know, you're not taking out an eighth of an inch of material. It's very, very small. You look carefully at that's going to take a while doing what you're doing. Look carefully at Players running around. I set my board so that color parts play a little bit. I want green on the outside and yellow on the inside. And then I'll go out and I'll buy something. Sportsman, I'm a fisherman. They played, so put them in the water jet. Got my fish plate. Put the blank in the middle, and I pull it down and shove it in the bag. Put the laser and let you go to sleep. You know, like custom fishing. Whatever. Like it's just, I'm limited in my own little vision of the world, but I can't wait for years. Coming in and sharing the creative work. See what I do. See you guys' eyes on the school video. About like that. Are we going to be pretty? But we can do a lot of good stuff. And then Eddie did tell me that this thing did. So it did just pretty. I mean, it did come right out. But what's crazy, you look at it, a little bit different thing. Look at it and see how thin it cuts. It's almost, it's very, very, very thin. This one I took home and ran. I polished it on my, my grinder. I have a wire brush on my grinder at home. So but that's how it can do. You know, and there's other technologies that do this. Plasma cutters can do this. And each of them have their own limitations of how accurate and what the edge cut is like. You know, what's really cool about these water sticks. Well, this is probably the last one. And we're gonna, I kind of hope that he wants this one or that one. Because I'm partial to do after a summer of learning how to make software work, going home this weekend, taking a hand drawn thing, putting it in the software, bringing it back, fine tuning it. This is what I'll give it to him. I got to hang this one on the wall first. Because I'm goofy. So it's for taking differential out of a lot or truck. The drive shaft goes into the rear end of the differential. This pulls in. And then turn it and just get out. It has the hole in it, half-inch drive ratchet. Square has a reason. All it really was, you know, it was an inner diameter. The most important thing was the center of these holes that had to be perfect. And then it's got an outer diameter. It had to be, the axis had to be, you know, if you notice the picture, they're vertical, 60 degrees. We've already showed them this one, and they actually tried it. The other two were us developing our ability to know how to stop when it doesn't go right the first time. Make the tool go too fast. It's like, hey, you can't shove a skill saw faster than it can cut. You can't drag these machines. It's that, so slow it down. really, I mean, yeah, I wanna, you guys have any questions? I don't. Love it if you guys stick around. Tell your friends, your students, your coworkers about it. We both look forward to seeing you guys sticking in here. Have any questions? Email me like, hey Ryan, do you think we might be able to do this? Shoot to me. I bring my students here, can I bring my coworkers? My next door neighbor wants me to try to build a whatever. Oh, did you? Box come out. Actually, it's worth a look because it's getting close.
I'm just saying like, this is so freaking cool.
Yeah.
Yeah, I didn't even know this was here like this.
You can open it, take it out, and everything.
It is all done.
Yep. Yeah. Oh, that's the new line again.
Oh.
Yeah.
That's, see how we're still learning too? Yeah. So, again, it's, as we get better at it, you know, this is what happens when you open up a facility. No, it didn't. You want to feel with your fingers, even though we can't punch them out and show you, because we got to run it, set it to go a little bit more intense, or either more intense or deeper. I just want you to feel how it actually does burn off the surface of the wood. So yeah, well, prototype. Don't get them right the first time. Like I said, well, the other thing too, you know why? Because the other one was plywood. Oh,
Thicker.
well, it's hardwood. Softwood, quarter-inch plywood. Yeah, it's the same thing that we figured out on that machine. Is not only were we going too fast, and when you told it slightly less dense type of steel, and we had it in so sticking it with soft material and it could go faster. So we told it, no, it's denser steel. We want a smoother pedal, slow it down. Same thing, that's what the 3 plywood. Yes, thank you guys for coming. It was really nice to have some people here in person. I got kind of tired of Zoom land teaching myself where you're sitting at home talking to a computer. So thank you guys for coming out.
Like this, you need to see this.
Yeah, I'm happy to kind of stay on if there's anybody who has questions. Oh, there you go. See, oh, see how that.
I'm watching this.
We ain't playing around no more. We turned up the heat.
Okay, we're at the big guns.
Yeah, get ready.
So, I think we don't use laser. Are you kidding? It's gonna turn out to be creative.
Does it have some safety thing to stop it from catching on fire when it warms up like that?
Yeah, so
Us, this,
it's
and-
positive pressure, so there's never enough time. Yeah.
well, if you notice, you know, we do have a sink. We've got high wash station. You know, you're over here mixing epoxies. You know, you can. It's accidents can happen. Yeah, stuff could happen. There's enough. You know, we've got pneumatic, like small finish rollers. And
There's that question.
There, good. Somebody did. That's what we want to hear.
That's so.
I'm gonna go ahead and just everybody at the risk of sounding sounded like we're showing off. Looking down below the workbench.
Yeah, hardwood.
Maybe you have to bring it from the other side, but that's, you have to like mirror it.
Check it out.
Actually, it's kind of good to text out on the other side, so then you don't have the noise and everything else.
Basically, got a little bit of everything. Yeah. So. Help. So that goes together. Probably come on. Not nearly as difficult as I thought it was. Yeah. kind of got to squeeze it together. You can feel it's got a tiny bit of, little tiny bit of slack, but pretty tight tolerances. Absolutely.
That one's glued.
Yeah. Tried to tell you on this one. This one is. Yeah, I mean, and I'm sure that the creator of the file would probably be okay if you asked them if you wanted to put, CRC printing or CRC, sociology or CRC. Whatever. I have a saw blade logo for my program. I just import my logo.
The logo's on all four sides.
Yeah. So, anyway. Yeah. So now you know why we kind of don't even assume first attempt doesn't usually happen just right. The other ones. In fact, I know none of my first attempts have happened just right. I think you got it, it leaves out something. So you do it. Still a fun learning process. Because we've got lots of opportunity, lots of exotic woods. And I'm going to make a pen. We're going to put use the blade and start making some little pens. Actually, and that's when we've done some epoxy projects. We actually have these little molds that ain't leftover epoxy. Put it there. And pens out of those parts. I appreciate you guys coming. And I'm happy to stay in this. But I'm not know if we feel all that. Stick around a little bit. Hopefully can conclude the scheduled flex Oh, yeah.
Yeah, there's that too.
Yeah, actually, usually when I come in, it's down a little bit. I think I got 8 by a thing.
There we go.
Very nice to have you guys come in. It's so cool. We have to figure out. I've seen you. Okay, I recognize. Okay.